We're going to look at graphing quadratic equations today. So standard form, from there, we have this formula. This formula is key to get everything started. That is the axis of symmetry formula. Let's start with that. X equals negative b over 2a. So my b value in front of the x, in this case, it's going to be negative 2. So I'm going to have my original negative from my formula. Then I'm going to put a negative 2 in there. On the bottom, 2 times a, my a is in front of x squared. Here I just have a negative sign. It's really negative 1, so let's bring that down. And let's simplify. You've got 2 over negative 2, or just negative 1. Now remember, that goes right in the middle. So negative 1. From here, we know our starting point from our t-chart. Let's either go smaller, let's go smaller and larger. So smaller, negative 2, negative 3, larger, 0, and 1. I now want to take those 5 numbers, pick them all up, and substitute them back into the original problem. But I also know I don't have to do all 5, because when we're dealing with a parabola, our answers start mirroring each other. So if I'm standing at negative 1, I take 1 step out. I'm going to take 1 step out. These two are going to have the same answer. If I take 1 more step and then 1 more step, as long as I'm taking this equal amount of steps out, we're going to have our answers that are going to match up with each other. So let's pick some of the easiest numbers to deal with. Let's start on the bottom. Let's start with the 1. I'm going to take 1, substitute it back in. So negative, the number that I'm substituting in, I'm putting in parentheses. 1 times 1 squared is going to be 1, but we also have that negative in front that comes down. They cancel out. You're left with negative 1. All right, so if this is negative 1, that also means that's negative 1. Let's do it again. This time we plug 0 in. Uh, 0 minus 0 plus 2, we end up with just a 2. If that's a 2, up here is a 2. Now our vertex. Negative 1 minus 2, negative 1, and 2, exponent. So negative 1 times negative 1 is going to be a positive 1. But then we need to bring this down. Now, each time, be careful that we're following the rules of order of operations. You always want to do exponents first, and then you multiply by that negative. Negative gives me a positive. So 4 minus 1 is going to give us 3. And since it's in the middle, there's nothing to mirror there. All right, let's take all 5 of those, put them on our graph. So back 3, down 1, back 2, down 2, back 1, I'm going the wrong way, aren't I? Back 2, up 2, back 1, up 3, over 0, up 2, and over 1, down 1. So you have your parabola. Now remember, it's a little more of a U shape, not V. V's or something else. So this graph opens downwards. Now there should have been a hint in the very beginning. Because there's a negative there, your graph is going to look like it's an upside down U. Negative means upside down. Okay, from here, let's find everything we can possibly find about all this. So axis of symmetry, first thing we found. X equals negative 1. Your vertex is half of that axis of symmetry, and then we found a 3 when we plugged it in. Vertex as a coordinate, I'm sorry, the y-intercept as a coordinate right there. So go over 0, up 2. We already found that, and for whatever reason, if the vertex is always going to have a 0 comma something, if there's not a 0 here, put 1 in and then find it if you have to. Max or min, so this graph forever goes down, always, but when you go up, that's the highest possible point we ever reach. We say it has a maximum. So it has a maximum height, and we're going back to the vertex. Where's that? Highest it goes is 3. We have 2 solutions, And what are those solutions? Now, be very careful. I know my graph is a little sloppy, but you can see that this blue line doesn't quite hit our lines. So I'm going to take a guess as to what our answer is. I'm going to put a little squiggle equal sign here. The little squiggle equal sign means about. Um, we almost hit 1, but I don't want to say 1 because I know it's less than 1. I'm just going to take a guess and say about 0.75. And on the other side, we've got -1, -2, -3. We don't hit -3 yet, but it's almost about 275, maybe a little more. I'm just taking a guess, and we put the squiggle about signs just to say approximately. Domain. Domain is what x values does this graph cover? Well, we're talking about left and right. This graph forever goes down. We know that. We can see that. But it also moves outward very, very slowly, but forever going outward slowly. Since it forever goes, we say all real numbers. And I got a fancy looking R there for that. This means all real numbers. We hit every number that way, every number this way. We hit them all. And then your range, that's your y values. So we'll say y, 1, 2, 3. So we start at 3, we hit 3, and it's our graph is 3 and everything below. Everything down is going to be smaller. Everything down is going to be less than. So we put a less than sign. Y is less than or equal to 3. And that is graphing quadratics.